everyone and welcome to my YouTube channel. Here's a brief introduction about myself. I am a BTech graduate and these are the subjects that I teach. So if you would like to connect with me for a one-on-one or a group session, please check out the description below. So let us continue the last topic that we did, and we are covering the ICSE portion, and this is the first chapter. And from the previous two lectures, we are starting off with the third lecture, and in this particular part, we are starting with the question number 11 under the numerical section of consigned physics. So, first of all, according to the question tells us that the figure shows a uniform meter rule placed on a fulcrum at its midpoint O and having a weight of 40 gram force at the 10 centimeter mark. That means there is a fulcrum which is situated at 50 centimeter mark of a 1 meter rule or a 100 centimeter rule, and the 40 gram force weight is kept on a 10 centimeter mark. So we can clearly see that there is a gap of 40 centimeter between this whole thing. And after that, a weight of 20 gram force at the 90 centimeter mark. There is another weight which is kept at the 90 centimeter mark. So the total distance is again 40 centimeter. So first of all, the question asks us, is the meter rule in equilibrium? So what do we mean by equilibrium? It means that the total moment of force of this particular portion must be equal to this particular part. So what we have to do now? So for that, we will be doing that W1 into D1 is equals to W2 into D2. Now what is my W1? It is the 40 gram force multiplied with the distance between the weight and that of the fulcrum, which is again 40, which will be equal to 20 multiplied with 40. So this will be 1600 and this will be 800. We can clearly see that both of them are not equal. So for that, I can say that this particular portion is not in equilibrium. So I will say the meter rule is not in equilibrium. After that, they are asking us, if not, how will the rule turn? So if I can say that from my common sense, this particular portion has a greater weight than this one, this means that this rule will go in this direction. So the direction will be over here, which is anti-clockwise. And the other one would be in the clockwise, because the total moment of force is anti-clockwise and equal to clockwise one. So the one having the greater value of moment of force, the direction will be in that way only. So I can say the rule will turn in anti-clockwise direction. Okay, so this was our first part number A. After that, they are asking us, how can the rule be brought in equilibrium by using additional weight of 40 gram force? So for this particular meter rule thing to be in equilibrium, as we can see that the total difference between these two is 800. Like if I want to make them in equilibrium, I need to cover up that 800 gram force or the 800 Newton part difference. So for that, I will be saying that 1600 must be equal to how much? 800 was already there, plus I need to put a 40 gram force at some distance. So I will consider that as 40 multiplied with D. If I take 800 to the left hand side, it will be 1600 minus 800, which will be equivalent to 40D. So now 800 is equals to 40D. So my D comes out to be 800 divided by 40, which is 20 centimeter. This will be my answer for the second part. Let's move on to the question number 12 according to the book. And in this particular question, it is said that when a boy weighing 20 kilogram force sits at one end of a 4-meter long seesaw, that means if I try to imagine this in a pictorial form, so there is a seesaw, all right, and the total length of the seesaw is 4 meter. After that, it gets depressed at this end. So it is in a simple way that um, in a seesaw there should be two persons sitting on the either side of that. But if a single boy is sitting of this much weight, that means one end of the seesaw will then be the lower level to the ground. After that, they are asking how can it be brought to the horizontal position by a man weighing 40 kilogram force. So first of all, for the seesaw, the fulcrum will be in the middle. That means over here the distance will be 2 meter, and over here also the distance will be 2 meter. If I consider that the boy which is sitting is over here, which is 20 kilogram force, so from that I can say that for the seesaw to be in horizontal position, over here the horizontal position plays a very significant role in this question. It simply means that I need to make this in equilibrium. Why? Because if it wouldn't have been in equilibrium, that means the seesaw would have been tilted a little. But for it to be in horizontal position, the whole thing must be in equilibrium. So now the same rule only. W1 multiplied with D1 is equals to W2 into D2. Now what is the weight of that boy? That is 20 kgf. Multiplied with the distance is 2. Weight of that man is 40 kgf. I don't know the other distance. So this will be 20 multiplied with 2 divided by 40, which is D2. So 20 2 times, 2 1 times. So we can say D2 is equals to 1 meter. That means that particular person must be seated at a distance of 1 meter from the center, which means that the other person should be over here at a distance of 1 meter. Now let's move on to the next question. And in this particular question, the question is telling us that a physical balance has its arm of length 60 centimeter and 40 centimeter. All right. What weight kept on pan of the longer arm? Longer arm means the 60 centimeter thing. Okay. So first thing over here, this longer arm means the 60 centimeter part will balance on an object of weight 100 gram force kept on the other pan. That means the 100 gram force is kept on the other side of it. Alright. So for that, if we start off with the thing, so first of all, the same concept will be going on. I will be writing that weight 1 multiplied with D1 is equals to weight 2 multiplied with D2. So now starting off with the first thing, what weight kept on the longer arm? So the longer arm is 60 centimeter one. So weight is unknown to us, write 60 as it is. After that, will balance an object of 100 gram force, 100 multiplied with to the other end. Now to the other end, it means that I have to write 40 over here. As simple as that. So the weight must be 100 multiplied with 40 and divided by 60. 0 and 0 gets cut off. 2 3 times, 2 2 times. So this will be 200 divided by 3, and we know it will be a like a kind of recurring thing. So I can write simply as 66.67 gram force. This will be my answer for this particular. Let's take up another question. And now this is a type of important question for exam perspective. So first of all, we can see over here that in this particular question, it is given to us that the diagram in the figure shows a uniform meter rule. Uniform meter rule means the whole rule is of length 1 meter or 100 centimeter, weighing 100 gram force, pivoted at as its center O. There is a pivot which is its center O. Two weight 150 gram force and 250 gram force hang from the point A and B respectively of the meter rule such that OA is 40 centimeter. That means this portion is A and this whole thing is 40 centimeter. OB, this portion is B and this whole thing is 20 centimeter. Calculate the total anti-clockwise moment about O. So, first of all, if we think from our common sense, we need to perform the moment of force. The moment of force is simply but force multiplied with the distance from the pivot point or the fulcrum. So I can get one of this particular as my answer and the other one this. So from my common sense, I can see that over here the distance is much greater. Alright. So it will behave in the anti-clockwise moment or direction only. So for that, for my first part, I can simply say that the total anti-clockwise moment is equals to 150 gram force multiplied with 40. From here, I will get my answer as 6000 gram force centimeter. After that, they are asking us about the clockwise. So the clockwise will be the other part of it. So total anti, my mistake, total clockwise moment will be 250 multiplied with 20, and this will give us the answer as 5000 gram 4 centimeter. After that, they are asking us the difference of anti-clockwise and clockwise moment. A simple thing for us. So the difference will be part C is nothing but 6000 multiplied with 5000. It is 1000 gram force centimeter. And after that, the distance from O where a 100 gram force weight should be placed to balance the meter rule. So again, the previous concept only. We need to balance the meter rule. For it to balance the meter rule, we must think in this way that we need to acquire the equilibrium thing. Now, as we can see, the whole difference was 1000 gram per centimeter. So, my only thing will be to just handle this part. If I'm able to handle this portion, it will be simple for me. So, if we go into the same way like we did in the first part of this lecture, I can say that 6000 gram force centimeter is the highest part. I already know that 5000 gram 4 centimeter is the lower half of it. So I need to place the 100 gram force in clockwise direction only. So 100 multiplied with d, and d will be the distance from the point O. So if we subtract both of them, it will be 1000. 1000 is equals to 100d. So what will be d? D will be 1000 divided by 100, and we will get the answer as 10 centimeter. So therefore, distance from O. So the distance from O, and we are considering the right hand side, it will be 60 minus 50, which is 10 centimeter right of O. Okay. So till here, we will be discussing the question in the next video. I will be completing off with this chapter. So I would consider that you may like, comment, and subscribe to my channel. Thank you very much.